labor, and would be successful in making 100 units. So is that good enough? Well, I don't think so, because we can do a little better. Here's why. We could actually reduce our cost with this red line, which is just a parallel shift to the left, such that we hit this point. So now we're using a lower cost of labor and lower cost of capital in order to get exactly the same number of units. So we can hit 100 units with a lower cost of manufacturing than this Isocost. We'll move to this Isocost and save money while not jeopardizing our production whatsoever. So this looks very similar to what we saw before with the indifference curves, where we had a budget and we had an indifference curve. Here we have a cost and an isoquant, right? So very similar idea. Instead of satisfaction for a consumer, we're looking at the number of productivity or the number of products produced as output in a manufacturing process. So learning objective 4 is let's use the isoquants and isocost to find the optimal unit combinations. So let's say we had a beginning point where we had this, where we had isocost hitting this nice isoquant at Q sub 0. Then, as the wage rate rises, we can buy less of labor, and now we have to make a change. It looks like this. As labor goes up in price, wage rate, this shifts over here because the same amount of dollars can now buy us less amount of labor. Now we're in trouble because if we want to make Q0, we cannot get to Q0 based on the current isocost line because of the change in rate. So what do we need to do? We need to raise the isocost. We have to get more money. So here, if we wanted to stay at A, which worked, right? It got us to Q0, we would have to raise by quite a bit our budget. So the isocosts are raised to here in order for us to afford this combination that got us to Q0. But we can do better. Why? Because you'll notice that this point is superior. By raising it less to this point, we can still get to Q sub 0, but with a different amount of combination. We'll move from A to B with less labor and more capital, but that combination gets us exactly the same quantity. So if we had this situation where the rate of labor changes, the isocost changes from this to this. Now, in order to hit Q0, we need to raise our budgeted amount, our isocost, to this new red line described by L1 to I, and this will get us to the point where we can hit B, which combination yields our target manufacturing quantity. So if we're a production manager, we'd say, yeah, we can still make you the target numbers that we always wanted, but I'll have to shift from this combination of labor and capital to this combination of labor and capital, but not a problem. We can do so and deliver Q sub 0. And we see that we did a good job because we could have moved out to the green line where we got to A, but it would cost us more money. By being imaginative, by substituting some K for L, we could move to this point B and spend less money because this isocost line spends less money than the green isocost line. So that's the job of the production manager, to hit a target number, Q sub 0, based on the best combinations in line with the cost of the two resources of labor and capital.